I had a request to do 4 of the problems from the semester exam review from chapters 2 and 3. And so the problem that I'm about to do here is number 5 off of that review sheet. And the problem basically wants us to draw 3 different lines P, Q, and R, that all go through the same point, -3, 4. So the first thing I'm going to do is plot this point, -3, 4. And I'm just going to work on drawing one line at a time. So let's see, the first thing that we're told is after knowing what point to go through, we're told that line P has a slope of 4. Okay, so let's just take that information and knowing that it goes through the point -3, 4, let's draw line P. So a slope of 4 would be up 4, right 1, and then down 4, left 1. And we'll do some colors just so we can keep these lines fairly straight. So let's do this one in blue. 1, 2, 3, 1, 2, 3, 4, 1. All right, and I think we're ready to draw line P. All right, and let's just label that. Here's line P. Okay, well, now let's think about line Q. What we're told about line Q is that it's perpendicular to line P. They didn't give us the slope for line Q. They just told us that these two lines are perpendicular. But we know that perpendicular lines have opposite reciprocal slopes. Opposite and reciprocal. Okay, so if the slope for line P slope is 4, then the opposite reciprocal, first of all, the opposite of 4 is -4, and the reciprocal of -4 is -1/4. So the slope for line Q is -1/4. I'm just using M here as the designation for slope. All right, so line Q goes through the same point, -3, 4, but this time we're going to count out a slope of -1/4. So we could go up 1 and left 4, or we could go down 1 and right 4. We'll draw line Q. Okay, and it looks something like that. So you can kind of get a visual here that where they cross forms a right angle. That's what perpendicular means. Okay, so let's label that as line Q. And then we got one more line to draw, and that's line R. All we're told about line R is that it can only go through quadrants 1 and 2. Well, if you don't remember the quadrants, let me label them for you. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we need a line that will never get out of quadrants 1 and 2. Obviously, that's going to have to be horizontal, and it goes through this same point, -3, 4. So here's the graph of that line. It's a little bit low. Let me try that again. I guess that's a little bit better. So there's line R. Keep these color-coded so you can keep them straight. And now we're supposed to write an equation for each line. So I'll start with the easy one, line R's equation. Since that's just a horizontal line going through 4 on the y-axis, that equation is going to be y equals 4. Okay, let's take a look at line P, the equation for line P. Well, again, depending on which method you like, you could start with slope-intercept form. And you can let, in this case, since we're going through the point -3, 4, you could let y be 4. You know the slope for line P is also 4. And x is -3. And we'll use this information to solve for B. So it looks like B is 16. So the equation for line P is going to be y equals 4x plus 16. That's the equation for line P. Okay, y equals 4x plus 16. And now we're going to do very much the same thing for line Q. Do that down here. It's just that we're going to use the same x and y, but instead of m being 4, m is going to be -1/4. So 4 equals -1/4 times -3 plus b. 4 equals 3/4 plus b. It's just -1/4 times -3. And if we go ahead and change 4 into 16/4, okay, hopefully you can see that. I'll just write it up here. 16/4 equals 3/4 plus b, and we subtract 3/4 from both sides. We get b is 13/4. All right, so the equation for line Q, y equals -1/4 x, or -1/4 is the slope we use, and then our b is 13/4. Okay, so we have finished this problem. We drew all 3 lines through that single point, and then we were able to come up with the equation for each line. So that completes problem number 5. Okay, let's take a look at this problem from chapter 3, solving a 3-variable system. This is number 19. This is one of those investment problems, and so since we're asked to find out the total amount invested in each of 3 funds, we need a variable that represents the 3 funds. So you can choose any variable you want. I'm going to let x represent the growth fund. I'll just abbreviate GF. I'm going to let y represent the income fund, or IF. And I'm going to let z represent the money market fund. I'll just do MM. Okay, well, let's see what we're told here. We've saved $3,200, and we're going to invest it, all of it, in these 3 funds. So the total amount of my investment, I should get a little more specific, I guess. This general fund represents an amount invested, and same is true for all these. So when we solve for these, we're going to be answering this question. How much was invested in each fund? Okay, so these variables represent the amount invested in each fund. All right, well, we invested all of our money, all $3,200. Issue here with my pen. Went into these 3 funds. So my first equation will be showing that all $3,200 got put into the 3 funds total. My next equation focuses on how much I'm going to get back. The reason why we invest is we're hoping to get money back. Well, we got a total of $250 back, and we got it back from these percentages times each of the investment amounts. For example, the growth fund earned 10%. So in other words, 10% times the amount I invested in growth got paid back to me. And 7% times the amount I put in the income fund got paid back to me. And 5% of what I put in the money market fund got paid back to me in the form of interest, for a total interest amount of $250. Okay, so far so good. And then finally, we read this sentence here that you decided to invest twice as much in growth as in the money market. So the growth fund, in other words, the growth fund, which is X, should be 2 times the money market fund. And at this point, this is one that tends to cause people trouble setting this equation up. What I would recommend is try what you have. Okay, I think this is right, but I'm going to do just a little check using some regular numbers. Okay, so for example, if I invest, so just using some small numbers, just imagine for a second that you invested $10 in the money market. In other words, we're going to temporarily let the money market fund be $10. Substitute 10 in for Z. Well, that means the growth fund is $20. Does that match what this says? I decided to invest twice as much in growth as money market. Well, that works out, because if money market is 10, growth is 20, or twice as much. So just a quick little check, because I know from experience some people tend to switch these variables around, and if you do, and you do that simple little math check, you'll catch that error, because what you will say if you switch these is that, well, it's just the opposite of what it's asking for. The money market will be twice as much as the growth. Okay, so we're ready to go. We got the system of 3 equations, and now we're going to use substitution, because in this bottom equation, the variable x is solved for. X is 2z. So we're going to use substitution to replace x in the other 2 equations with 2z. Okay? See if I can squeeze that in right here beside. So just imagine that in this red equation, x became 2z. All right? I'm just literally substituting. And I can combine like terms with the z that's already in the equation, and I get y plus 3z is 3,200. Okay? And I'm going to do the same thing here. I'm not using a calculator right now, so I wonder if it's okay with you if I change these decimals into regular numbers, and it's always okay to do this. If I just slide that decimal 2 places to the right, 2 places to the right, all the way across, including this number, taking the decimal at the back of the number and moving it 2 places to the right. Now I'm working with this form of that equation, which for some people just it's just easier to work with because they're not looking at decimals. Okay, so let's just imagine now that we replace, now we're working in this equation, just a different form. We're going to let x be replaced with 2z. Well, you can probably see that 10 times 2z is 20z. And when we combine like terms, 20z plus 5z is 25z. All right. And now we have a system of 2 variables. We had 3 variables, now we're down to 2 variables, and we can use elimination. So let's see, I'm going to eliminate y. And the best way to do that is to multiply by -7 on the top equation. I'll put that over here. All the way across, I'm going to multiply by -7. which makes negative 7y minus 21z equals negative 22,400. Okay, so that's the result of multiplying by negative 7. And now I can add to eliminate y. So the y's cancel. Negative 21 plus 25 is 4z. And negative 22,400 plus 2,500 is positive 2,600. Dividing both sides by 4 gets me my first investment amount. I know that we invested $650 in the money market fund. And I've got, according to my original system, I have a real quick and easy way of finding the growth fund because we were told that the growth fund should be twice that amount. So now that we've found Z, plug Z in, 650 in for Z, 2 times 650 is 1,300. All right, 2 of our funds have been found, and now we've found the third one. We find the third one by going back to this original red equation. And I can replace the x with 1,300, solving for y, replace the z with 650, and I'm going to be taking 1,950, 1,300 plus 650, and when you subtract 3,200 from 1,950, that should be 1,250. Okay, so hopefully you saw how we are able to solve for y. All right, and you could do a little check, just to make sure. If you have time on the exam, if you add all these up with your calculator, does it equal 3,200 like it said it's supposed to? And it does. So those 3 amounts total up to 3,200, so we feel pretty good about our answer. All right, so that's the finished answer for number 19. Also had a request for this linear programming problem, the pizza shop problem. And so right off the bat, we'll just take this just a sentence at a time, and we'll break this up into parts. The first sentence basically describes how the pizza shop earns profit. Okay, it's another way of giving us what the profit function is, and ultimately that's the goal of this problem. How am I going to maximize profit? Well, if I'm going to maximize profit, I need an equation to use to represent profit, and that's what this first sentence is going to give me. Okay, this pizza shop sells small pizzas and large pizzas. So again, variables. Let a variable represent the sales of small pizzas and another variable, in this case y, large pizza sales. Okay, so my profit function based on this information is I'm going to make $1.50 times every small pizza that we sell, and I'm going to make $2.15 times every large pizza we sell. So that is my profit function. It's not anything that needs to be graphed. We do not graph the profit function or the cost function if you have a problem like that. This is going to be used at the end of the problem to plug in vertices and for x and y to see which vertex gives us the highest number for P. Okay, so let's move on. We have on a typical Friday, this pizza shop sells between 70 and 90 small pizzas. So let's just take this phrase, the small pizza constraint. Okay, we sell at least 70 but not more than 90. Or in other words, the sale of small pizzas is between 70 and 90. All right? Now let's look at the large pizza constraint. We're going to sell on a typical Friday. We're going to sell at least 100, but not more than 140. Okay, that's the large pizza constraint. And one more constraint. We cannot make more than 210 total pizzas a day. So if we take small and large together, add them up, how much we make, we're not going to make more than 210. Okay, and we're going to be graphing this line eventually, so we might as well go ahead and get it in slope-intercept form. Solve for log. Okay, well, we have our system of constraints. I would add one more, or actually two more, which are pretty much understood. I probably should have mentioned this in class, but it should be obvious to you that we're not going to sell a negative number of small pizzas, and we're not going to sell a negative number of large pizzas. So those are constraints. They probably make sense, probably obvious to you, but they should be included. Now I went ahead and just gave you quadrant 1 of a graph, which might eliminate the need for drawing these, but they really should be included as part of our system. Okay, now I'm going to change my units into 20, so maybe just to make these less confusing, we'll just say mark these numbers out and do 20s, 60, 180, 200, and 210 or 220. All right, and we'll do the same thing going this way. 20, 40. Not sure you have to mark the numbers out, but it might make it a little bit less confusing if you do. Okay, 20, 40, 60, 81, 20, 40, 60, 82. Okay, so you get the picture. All right, so let's start graphing our constraint lines. Starting with the red constraint for small pizzas, we're going to draw a line that would be x equals 70, right in the middle of 60 and 80. And another line for x equals 90. And since it's an inequality, we'll think about what it would look like to shade between these. Okay. Now the blue constraints, y equals 100 and y equals 140. And we would shade in between these. So if we combine the red and the blue shading, so right now we're in this area right here. All right, let's graph that constraint on the total number of pizzas that we can make in a day. All right, so I'm going to guesstimate 210 to be maybe about right there, about half of a distance. And we'll do our slope of down 10, right 10. Okay, down 10, right 10. Let's see if I can get this line. It needs to be a little bit lower. It's pretty close. Okay, so we can kind of see our vertices here, And our feasible region will be this shaded area inside. Okay, so let's list our vertices. Here you can see that this is 70, 100. That's 70 small pizzas, 100 large. Here, this vertex is 70, 140. 70 small, 140 large. This vertex is 90, 120. 90 small, 120 large. And this is 90, 100. 90 small, 100 large. Okay, and now it's going to be our job, and I won't take the time to do this. At this point, you're going to grab your calculator, and you're going to plug these 4 points, X and Y, into your profit function. Again, the goal of this problem is to maximize profit. Which of these ordered pairs, combinations of small and large pizzas, would give you the largest number for P? So when you test them, you should find out that the combination of 70 small pizzas and 140 large pizzas would give you the maximum profit. And we didn't ask in this problem, the problem didn't ask us to give that profit number, so you don't have to worry about showing that. You just need to figure out by plugging in which one would give you the maximum. Okay, we got one more. We have these 2 companies, and we're trying to decide which one to go with, and they charge their customers a little differently. So let's write this system of equations to represent the cost. All right, so let's do the internet action. I'll just abbreviate it as IA, internet action. They charge us cost, C, equals, and the other variable we're told to use cost and T for hours. Okay, so C, cost for internet action, is $2.25 an hour, 225 times T. And then they've got this monthly fee. It's not really based on hours of use. It's just a monthly straight up charge of $9.95. So that equation would represent the internet action charging structure. And then we've got Webster's Web. They charge us a little differently. It's strictly based on usage, and it's $2.95 for every hour we use it, and then they don't have this extra fee each month. So what I would do first is, since you're going to have to do this anyway, we're going to solve this really in 2 different ways. And let's solve it first by using substitution. Let's replace the red C with 2.95T, since we've said in this equation that C is 2.95T. So 2.95T is equal to 2.25T plus 9.95. And if you solve for T by subtracting 0.25 from both sides, you get 0.7T equals 9.95. Thought I had a calculator that I could use. I'm going to do somewhere. Let's see. Sorry about that. I thought I had a calculator I could pull up on the screen, but anyway, you're going to do 9.95 divided by 0.75 or 0.70, and rounded, that would be 14.21. 14.21 for T. Remember, T represents hours. Okay, so to find C, we can plug into either one of these. So I'm just going to plug into the bottom one. C is equal to 2.95 times 14.21. And let's see, 2.95 times 14.21. That is 41.92. Okay, so what we found is the ordered pair 14.21, 41.92 should be the point where these two lines cross each other. And it's another way of saying at 14.21 hours, both of them would charge us the same amount of $41.92. So this is at the point where we're going to interpret the meaning of this intersection. This is the point where both of the companies would charge us the same amount after 14.21 hours. Okay, so let's do the graph. T is our x-axis, so we're going to call the x-axis hours. And the variable C is really in place of where our y-axis normally is, so we'll call that cost. And I think the easiest way to graph these is to do a couple of table of values. I'll just go back to the colors I was using before. I'll do a table here for internet action, and then we'll do a separate table here for Webster's Web. Okay. All right, so let's start with internet action. Just start plugging some numbers in for what would be the X variable, the independent variable. Start easy. And sorry about that. Let me use the same so you don't get confused. I'm going to do T and C. T and C. Okay, so for internet action, at 0 time or hours used, they're still going to charge us $9.95. For 1 hour of use, they're going to charge us $9.95 plus $2.25. $9.95 plus $2.25, $12.20. And let's go one more. For 2 hours of use, they're going to charge us $4.50, which is $14.45. All right, so let's plot these points. Let's see, we need to be able to plot 41.92. So I'm going to just do these in fives. And I think I'll do both the X and the Y in fives. All right, 0, just shy of 10. 1, which is just a little bit to the right. And this gets a little close here. Tough to do with this pen, but if I go right, what I would think 1 is, just barely right. And then I'm up a little bit above 10. 2, and just shy of 15. Sorry about that. Okay. And let's connect this line, connect these dots. Something like this. We'll just see if we're in the neighborhood. Okay, let's get some points for Webster's Web. If we don't use it any hours, The web is not going to charge us any dollars, so that one's easy. If we use it for 1 hour, they're going to charge us $2.95. If we use it 2 hours, it's almost going to be $6. It'll be $5.80. So 1, and this is really tight. $2.95 is about halfway. And then 2 is a little above. And we'll draw this. Okay. So hopefully where my intersection point is, and it doesn't have to be exact, I know where it should be. 5, 10, I'm a little bit short. 14 is about right there. But again, I'm just doing rough estimates of where these points are. Let's see about the y-axis. 5, 10, 15, 20, 40. Yeah, it's a little bit low. And so if this were a test problem, since we're having to make guesstimates about where 2.95 is, 5.80 is, that's no problem. We're pretty close. Solving it with another method tells us exactly where we should be in terms of the intersection. So we're pretty much done. I think we've done everything that we were told to do. Interpret the meaning. Again, that's the intersection is the point where the two companies would charge the same after a certain number of hours, and we solved it using substitution. So I hope that helps, and that's your final solution to these 4 problems. Let me know if you have any other questions.